Hello everyone. We would like to represent our work, experimental study and mathematical modeling of face milling forces of high strength and high viscosity shipbuilding steel. Mechanical processing of hull edges in large-sized hull structures with single and double cavities for welding with saturation parts is an urgent task for the heavy machinery and shipbuilding industry. The edges of hulls in the thick-walled hull structures where these parts are installed must be beveled to perform welding. A considerable amount of the bevel machining has to be performed directly on a fully assembled structures in the slipway. To perform such works, non-stationary technological multi-axis complexes, abbreviated as NTAs, with computer numerical control are used. The main aim of this article is to develop an analytical mathematical model of the cutting forces acting on the edge surface of the hull structure. We planned and conducted a factorial experiment of speed face milling of a workpiece from the hard to processed steel, which is used for the production of ship hull structure. We determined the depth of cut, the speed of the main movement cutting, and the speed of the forming movement, the feed rate, as the influencing factors. The cutting forces components have been measured for each experiment. The diagram on this slide shows us an example of the oscillations of the cutting force components. In the experiment, cutting forces were measured over the entire cutting section, including the plunge and exit areas of the cutter from the material. The steady-state cutting section was used to determine the average values of the cutting force in order to create a mathematical model of the face milling process. The steady-state cutting area was highlighted and represented by separate array. Based on the analysis of steady-state cutting data, a graph of the oscillations of the cutting force component and the graph of the maximum force rate during the cut-down milling are presented on this slide. The following mathematical models for the milling force components, radial and tangential, were obtained using regression analysis. The two upper equations are given for the cut-up milling process, and the two lower equations are given for the cut-down milling process, respectively. As we can see on the figure on this slide, the dependence of the cutting forces on the depth of cut is of the greatest importance, as well as the degree indicator for the depth in the equation has the greatest absolute value within the investigated limits. In some cases, the dependence is close to linear. The dependence of the cutting force on the cutting speed within the specified limits has a non-attenuating character for cut-up milling, whereas for cut-down milling process, it has an attenuating character. The conducted research has confirmed the possibility and expediency of high-speed milling of parts made of hard-to-process steels with special viscosity and strength properties. Thank you.